they're basically quantifying how much money healthcare organizations are spending to get metrics. And especially like in startup land, but also iteration, it also ties into like Tesla and a lot of the ways sort of like Elon Musk does things, but that you have a number that you're optimizing for. Even the digital self-management system that you had a great chat with Joe Justice about, right, is basically you put in place a system that can quantify and give people back very rapid feedback. And of course, it has to be good, a good metric, but then you can then improve on that. And healthcare has done terribly in many senses because there isn't a good number for healthy, right? Be like, oh, people like, oh, I know what healthy means. You either look like you're healthy or not, but like, that's not a number. And there's actually a lot of nuance and disagreement on it.
Hey, y'all, it's Dr. Know-It-All. I have the privilege of being with Pedro Teixeira again. He is the co-founder of PredictionHealth, which is a company that is utilizing artificial intelligence to help make healthcare better. And we are today, Pedro is going to walk through some cool, fun little examples of using ChatGPT's new code interpreter that is now available to most of us. And just look at some examples. And then we're going to talk about how this relates to both Tesla and also to healthcare, which is a very, very messy data science regime. I guess you might call it that. So anyway, first of all, big welcome. Thank you so much for being here.
Yeah, so super happy to be here again. I mean, it was a lot of fun last time, and there's so many things that happen in AI and tools in AI. So I'm really excited to go through and talk about one of my favorite things, which is, improving healthcare by using AI and metrics.
Right. So cool. So yeah, I guess let's just go ahead and I guess we can go ahead and start with just a little example. And you were showing me this before we started the recording, but yeah, but go ahead and let's take a look at Code Interpreter here. So if you can share your screen, that would be super cool.
This of course came out, last week, or like was more broadly available. I think folks have been really excited about it, right? But the Code Interpreter using like the GPT-4 model in ChatGPT.
Right. And by the by, you had to point this out because it wasn't there previously, but if you're in the main, you have to have ChatGPT Plus, which means you're paying the $20 a month. But if you go down to the bottom left where it says settings, click the settings, go to plugins, and there should just be a little radio button or whatever slider that you can turn on Code Interpreter. And then you select it when you choose GPT-4. There's like a drop-down menu and you can pick that from the thing. So anyway, just for people, if you want to play along, you're welcome to do this. Because Pedro, you just we don't have this data set. You just asked it to generate the data set, right?
Yeah, and that's I was actually doing the same thing. So we have, of course, healthcare data. This is not HIPAA compliant, so you can't just like shove PHI in for it. But you can make it. You can ask ChatGPT to make fake data, right? So, or you can ask it to kind of like try to make tables. So this is one of my favorite features because otherwise you have to go look up, and spend a bunch of time on Google and copy paste it over. So in this case, the folks love the Tesla and the whole EV space. I do too. So I just asked it like, hey, give me a table with some cars by Tesla, VW, and GM, and give me miles versus price, so that we could do a little bit of visualization using the Code Interpreter now.
I just want to point out here that you did not say EVs, but it figured out since you had Tesla and you were asking miles versus price. I mean, it's pretty smart. Like that's not. It's not obvious. It could have given you gas cars and all sorts of other things, but it obviously figured out that you wanted EVs.
Yeah, it's really cool how it like thinks about like the probabilistic space of things, and you might even notice, when it's doing like really clever things like that. It's like, oh, of course I wanted EVs, but yeah, I did not ask explicitly for EVs. So I thought that was funny too. So here it just gave me a table. So I've got the manufacturer, the model, approximate range in miles, and the price. And all I had to do was ask it, and it just made this. And you can copy paste this out into like a spreadsheet if you want. But then the data is now available within the Code Interpreter to go and do stuff with. And I spent a lot of time cleaning data and then visualizing it so I can understand what in the world's in here. And it's really nice to just have the ability to ask it to do things for you. So then I asked it to just make me a little scatter plot of range versus price. So you can show this code, or if you don't want to see it, you can hide the code, but you can always grab this and go take it into your favorite Python, interpreter and run it. But it just pulled this in nicely into that from the table, made the data frame, and then now it's graphing what I asked it to do, right? Which is range versus price as a scatter plot.
Right. And very interestingly, it doesn't, you don't have to run this in a in a Python interpreter. It'll run inside ChatGPT, which is super fun. Yeah.
Yeah, I think probably most of the folks, or basically everybody that's been doing code stuff with ChatGPT has been getting really good at copy pasting rapidly between,
Right.
you know,
So this saves that round tripping time. And then of course you just asked it to make the points larger. So I'm sure, I don't know if we actually looked at the work, but I'm sure that the Python code just has some sort of non-default like setting for the size of the points.
There you go. It's on S
yeah,
equals
there you
1
go. Yeah.
for increased size. And then it actually added the comment to give me the indication.
Oh, yeah.
Here's
awesome.
where it is. Like it's so wild. And I'm really bad at like quickly like going through docs, and it takes me a while. So it was really nice to get that. And then they're a little bit bigger here. I could have been more specific probably and said like make them huge.
Yeah, right.
It
but still, it understands, it rewrote it, it's got all the stuff, and it even commented it, because at the top it actually has that S equals the parameter and the scatter plot for size. So it actually is teaching you at the same time. It's like, oh, this is how you would do it if you wanted to. So yeah, very, very cool.
Yeah. My understanding is also that when they're doing this like work step, that if it writes something that's not good code, it will get the error message and like redo it, because it's getting, like I've been copy pasting and it'll get something wrong and then I'll get an error. So then I'll copy paste the error back into ChatGPT and say, hey, can you fix this? This is the error I got. And then it'll get it right, after a couple tries. So I think they've incorporated that into the, little loop of trying to do stuff.
Right. Right. And that sounds like the what is that, LangChain? It sounds like they've got some of that going on, which it started off very, very interesting, but a little bit kludgy. But if you can get it to iteratively improve its own self, that's really impressive stuff. So yeah. And you can add your own data set and everything, right? You don't have to use just like some made up data set. You can actually insert a CSV file, an Excel file, something like that. So there's a lot of cool stuff. Oh, a regression line. Awesome. That's great.
Right?
Wow.
It's just so wild, right? I got the fake data or not fake. It actually seemed like it's mostly pretty close to the actual numbers. Pulled it, upload the CSV. That's the plus signs here for uploading file, which is cool. Yeah. But then, like I don't remember how to do the regression, or if I want a different kind of regression or association, you could do it. You could imagine actually probably getting it to pull in data, visualize the data, and then train a machine learning model, or at least give you the code to do it.
Oh my gosh, that's true. And my wife is a big Excel user, and she wasn't using code interpreter, but I believe it'll do that too. You can say, make this an Excel spreadsheet formula or something instead. And so if you wanted it to do the linear regression in Excel and generate the code for a visualization, a graph, it would be able to do that too. So very, very cool stuff. All right. So that's fun, but what does this have to do with medicine? So that's the next thing. Maybe let's stop sharing screen maybe. So yeah, there we go. Yeah. So tell me why does this have to do with medicine, and why is medicine difficult just why can't you just pop in some cool data and automatically get this stuff and be done?
So that is the key observation that myself and my co-founder had when we started this whole thing, is that, great, AI in healthcare is awesome. We can do so many useful, wonderful things. But then the question that we had is, if you are going to have an AI model to train to do something useful, you have to give it an objective function. You have to give it a score that it's optimizing towards, right? You need a label at the end of the day.
Yeah, and if for people who might not, objective function is a term of art, I guess you call it. Basically, it's, I don't know, if you're playing chess or something, it's the rules. It's like, what are you trying to do? Well, you're trying to checkmate the other person's king, right? So that's an objective function for chess. So okay, so continue on. Yeah.
So I could run with the car thing, right? So we had descriptions of the car, like it's had the manufacturer, you could get the color, you could get some features for the car, and then at the end maybe you're gonna have price, and you want to predict like how expensive the car is to figure out if you're getting more features or less relative to the cost of the car. Okay, so if you try to think about the healthcare system in sort of the same way, it's like we have patients, and they're gonna maybe have diseases or medications that they're taking, and then you have an output or a label or like the outcome that you care about. And you could try to predict if they're sick or not, or if they're going to, have some bad outcome, or if they have a disease. Those are very reasonable things to do. But what if the output label or the output number that you want to get is healthy? Like I want to predict if the person's going to be like more or less healthy than somebody else. And that's where it gets really tricky, because it'd be like, oh, you can look at somebody and tell, like, are they healthy or not?
Right.
But
Right.
you know, if you're walking through the hospital and you have a bunch of patients in there, and you know, you're trying to figure out, you know, is Mr. Jones or is you know, Mrs. you know, Smith, you know, more sick, you know, or healthier?
Right.
Like, okay, what's the number? You know?
Yeah. Yeah.
And that's where it sort of started like getting to the point where like, oh, this is like really, really hard, because ideally if you had a good number, then you could try to predict who's going to be really sick and who's not, and then how healthy they're going to be over time. But if you don't have that number, now it makes it really hard to do AI for the problem that we want to do the most, right? We wanted to help optimize for people to be the healthiest and to use AI to do that. But the score, the label, the output, or the objective function, right, that we were thinking about,
Right.
like we didn't have a good number for that. And if you don't have a good number,
and I guess in fact, it's not just one number, but there could be dozens to 100 numbers. You know, there's different blood counts, there's vitamin levels, there's do they have like arthritis, whatever. It's like there just could be so many different possible objective functions and just factors in an objective function. So yeah, it's obviously very complicated and messy, as are humans. As are we all.
Yeah. Which, you know, is part of the reason I love healthcare so much, right? The body's really complicated. It's very interesting because it's so complicated, but then it's also then hard to like fix or improve it. And you know, because you could look at strength, you know, like how strong is somebody, but then that even breaks down. Like, are you thinking about their upper arms? Are you thinking about their legs and how strong they are there?
Or
you know,
or like strength versus body weight, things like that. So, you know, obviously there's, yeah, different, there's so many different measurements. Flexibility is also like, so yeah.
Yeah.
That's near and dear to my heart. I'm very bad at flexibility, so I always think about that one. So yeah.
Yeah, it's hard to keep that one up. You gotta some stretches here and there. So lots and lots of possible numbers. Really hard to come up with a number for healthy, as you pointed out, right? It breaks up into so many different ways that you care about, right? Because it's strength, and then ratios. Because if you're a bigger person, you're probably stronger just because you're a bigger person versus like a really tiny person, and it just gets really, really messy. And so, you know, for our company, we pull a lot of the data out from the notes that people write to describe their patients, because they might say like, oh, Joe's pain is worse today, or like, you know, Sam's, you know, feeling more down, you know, his mood is not improved. Like none of these are numbers, right? Like how do I track this? This is the last time you wrote it. You know, is it a 7 or is it a 5? And there's a lot of problems or challenges that involve this step first, right? And AI is so cool because you can use it to take something unstructured and get it to some sort of like actual number, so that you could probably try to have something like a digital self-management system, right? That you had the wonderful chat with Joe Justice, and how Tesla uses AI to look at people moving through space and turn that into numbers for how good the paint quality is on one of the vehicles, or to do these automated tests. Because once you give people numbers, they have something that they can optimize for and improve over time and make decisions individually and get things better and better over time. And that's what I really would love to get to in healthcare, is get the numbers, empower people to have something to improve. That you have to pick the numbers well, right?
Yes.
And there's so many exciting, I think, things that like chat about with these tools, with other technology to get there.
That's fascinating. I want to talk about that number. That would be really cool if we did have a magic number. If it's like your number is 42, so you're super healthy or whatever. So, but first of all, I think you sent me this. What is it? A Johns Hopkins study, I believe, or no, it was a study that found that Johns Hopkins spent more than $5.6 million and 108,000 hours to report 162 measures of healthcare. And there's a graph and everything. I don't know. I could put that up if you want, but the incredible amount of human hours and expense that goes into this stuff, and how AI not only could help with doing a better job, but also scaling it, right? So that you can do more of this where it doesn't cost so much money anymore.
Yeah, that has been such a huge thing. And I mean, I'm sure many of your folks that you have that watch, you know, if they're in healthcare at all, you'll bring up the electronic health record and they'll immediately like it's burning them out, right? Burnout is a huge thing because they shift that system so they could put the data in the digital format. And the promise was, this is going to go in and we're going to have all this data and we're going to help improve everything.
Right.
But the way it's been implemented and what people are really focused on, the numbers aren't like very well aligned with what does it mean to like be healthy. There's a lot of process metrics. And so the Johns Hopkins thing, a lot of it they're pulling is like, are certain people taking certain medications if they have a disease? And it's like the process that should mean that you're healthier, but very few of the metrics you could sort of clearly say should be part of the final score of like how healthy somebody is, because it's so hard to get that final score as a good number, especially when people are typing things out and just kind of the other ways they would describe all these different things.
And I think that gets to the kind of a sparse reward system, the sparse reward game, if you want to. Again, it's sort of like I don't know, Mario Kart or something, where you win or lose the race, but you only find out after you do 3 laps around and several minutes of racing. And it's like, that's a really sparse reward system. And so in order for it to back up, you have to have very, very sophisticated AI. And of course, medicine is way more complicated than a racing game. And so you've got a messy data. You don't know exactly which metrics you need to be measuring. And it's a sparse reward system, because it could be years before you find out whether that person's outcome was good or not. It's like, was eating vegetables and going to the gym good? Well, let's wait 20 years and find out, right? It's like, well, that's really sparse reward system right there. So how do you deal? I assume your company is obviously trying to work on this and come up with some metrics that can be measured. How do you, this seems just like such an overwhelming problem, I guess, at least from my point of view. So how do you get up in the morning and not just go like, oh, this is too much?
Well, mostly because I'm foolishly optimistic. So kind of keep
cheers. There you go.
Right? I think we can do it. We'll figure it out, right? But I love the metaphor, right, of the sparse reward, because it's totally true. And if you look at most scientific papers, you'll get like all-cause mortality, which is like the very end of the game, unfortunately, right? And you need to back it up to have things to optimize for in the middle. So often folks will use a risk factor. Like they'll know that there's a blood value test, or BMI. BMI is a good example, actually, because of how good and bad it is.
Yeah.
Is there a correlation? So BMI being the body mass index, so like weight versus height for a person. And so like that will roughly correlate with health, because there's, whether or not like you're overweight, there's metabolic things that are likely to be off if you're really overweight. But also if you're like a really strong person with a lot of muscle mass, you could have a BMI that's very high, but you could be very healthy because it's muscle and like you run.
I actually will raise my hand to that one. I've always been on the edge of obesity, and it's just because I have a lot of muscle mass in there. So the doctor looks at the BMI for me and she says, don't worry about that, because it's not applicable to you. And it's like, well, okay, so that's one number. It seems like a great number, except it doesn't work in all circumstances. So yeah.
Exactly. So a lot of those intermediate numbers, the risk factor numbers, depending on like what you're looking at or the different types of patients, right? It may or not really be helpful. But that's what people kind of use as between the sparse rewards as like their thing to figure out, like, are we moving roughly in the right direction or not? Blood values, people look at cholesterol, but like the actual like risk factor between your cholesterol number, like an LDL, versus if you look at somebody like is metabolically unwell, like diabetes, I think is something more in the range of like a 5 to 6 fold, whereas like the LDL is a much, much smaller number. But that's the thing that people keep focusing on, because diabetes or not is 0 or 1, but then the LDL actually gives you like a number that you can get like, okay, it's 170, 150, right? But the other is actually more predictive, right? But like people don't necessarily sort of like realize that sort of swap between those two things. So how do we go about it? We take a lot of the stuff that people write, and we have these AI models that read through and then sort of turn into a number, almost like a rubric. It's sort of the same problem. So you have an essay, you've wrote your essay, and at some point the person has to give you a number so they can see if you've passed or failed the course, right? But it works. So we have models that will go through and they will read, and we turn it into a rubric of like, okay, how much risk? Did you talk about the person's symptoms? How complicated do those symptoms seem? And those all turn into numbers that we can then combine in thoughtful ways, so that we can say like, this is a great note, or this is a really complicated patient, or this person's doing a bunch of exercises and physical therapy and they're improving, right? And they're improving this much, and then insert number. And that's like the mechanism for us to get a number, so then we can make visualizations and dashboards and try to help people improve.
Gotcha. So I guess, is the first step then just better data entry? You said something about like, Mr. Smith or Mr. Jones or whatever is feeling better today. It's like that. It's like, is there a way for AI to directly interpret something like that? Or is incumbent on us humans to input the data in a form that's more amenable to the way that AI likes to think, which is a number.
So this is one of my favorite problems, because step one is, if it ever involves saying the person needs to do X and everybody needs to remember to do X, I already know that like that's not going to go well, because I've seen the data and it's such a disaster. And it's understandably very difficult to get everybody to input things the same way every single time consistently. You're basically never going to get that. So we rely on the models to take the reasonable ways people type things out and turn that into a number, and don't actually have much of an expectation for the folks putting the data in. Right. You know, they're rushing, trying to get things done. If you're some folks are finishing their notes at like 2 a.m., 3 a.m. to catch up. And so, you know, it's not a good expectation to have them do on the front side. Right. But if I were to tell you, like let's take knee pain. So if I say, hey, like John's knee pain is mild, okay, versus if I say it's very severe, he's not able to walk, he can't put any weight on that leg. Right. You know that one is worse than the other, right? Yeah. Yeah. So we can teach it by sort of like giving it examples of how to map it to the severity, to then take, you know, for lots of samples, these lessons of like, okay, like, you know, it's a 0 to 10 scale, and really, really severe, can't walk at all is like a 9, and mild is like a 2. And you can actually train the models to then get this text description of things. And it's able to be like, oh, okay, this sounds more severe. It's like these examples I saw. And you end up getting these numbers out by teaching it those relative differences in the free text descriptions of how the person is.
Gotcha. So you're actually, so one of the big things that you're doing, and I guess to tie this back into Tesla again, is the sort of auto labeling that they've got, is you're using AI to do to filter the data and try to put it into better formatting for a later AI. So it's kind of multiple steps of this. You've got one that's just trained to go like, okay, let's take human language and try to turn this into some numbers that we can deal with directly. Yeah. And I guess that makes sense. I mean, you probably don't need to be too much more accurate than the scale of like 1 through 10 or something, right? It's like almost no pain up to like kneecap is shattered or something, right? So you've got, you kind of know what the range is for knee pain, and you probably don't need like a 2.35 or something. You don't need that much accuracy to have a reasonable idea of it. Or do you actually need something really, really accurate like that?
For some use cases, you do need like a lot of precision, but I think the thing that like helps a lot here is, if you ask like 5 people and you gave them all the same exact description of how to score stuff, they wouldn't always perfectly agree. Yes. You might even agree with yourself if you're like before lunch and like you're getting kind of tired, versus like, you know, you're in the morning, you're having your coffee, or you're in a bad mood. People will really be very irregular in how they score things. The model is going to be very consistent because it's just some code and some math that's running. So if you give it the same input in the morning or at night or in 3 weeks, it's going to be the exact same answer. So its internal consistency is really great, because then the trends over time, even if like you could argue like, oh, it could have been a 2.3 for this type of thing, but it gave it a 3.2, you know, but over time it's really consistent internally and across all the data. So it's a lot more sort of fair to have this thing run and analyze people's notes than to say, you know, it's people who may or may not be tired or grumpy or, you know, just through their scores, you know. I think.
Okay. And that makes sense. And, you know, again, it's, I guess to some extent, I hate to belabor data, but data is also just such a crucial, it's what I think most people spend, and machine learning spend most of their time working on and worrying about is data. But it's, again, with human beings and with doctors or patients, I know I go into like, I don't know, I go to the chiropractor once a month, and it's like, it says, rate your pain. That's the first question you get when you get in. And it's like 1 through 10. And I'm like, so it's always like a 5 or 6. It's like, whatever. It's just kind of in the middle. There's some pain, but somebody else might have the exact same level and say 2, and the other person might have the exact same level and say 8. And so I guess the internal consistency part of that is just that across a lot of people, it's going to sort of even out. It's like if some people just tend to be a little more like they report higher pain for the same amount, it's just going to sort of shift that Gaussian a little bit to the right or something. but it will be internally consistent once you've got that model. And so it won't be constantly wiggling around. So yeah, so that it sounds like the internal consistency more than an exact number is really what you're going for here is yeah. Okay. All right. And then, so what do you do with that data at that point to make, to do what your company is, which is predict? So yeah.
Yeah. So then we get that data in. And so we have two main use cases for folks right now. One is compliance. So for physical therapy, there's a lot of rules about exactly how they have to write the notes. And so if they're not compliant, they actually can have the insurance companies come back, like look at some of their notes, and they'll be like, hey, 10% of these are not, X, Y, and Z. They miss these check boxes. So then they'll just take that money back. So it's a problem that they care about a lot. Is compliance fees. So our AI, because it doesn't get tired and because it runs really fast, we actually can run every single note through, and it'll read all the sentences and say like, hey, these are not so good. These are pretty good. Here's exactly what you could improve your score on, so that then you can improve it. And then if you did, get audited, you wouldn't have as big a percentage at risk of getting, taken back. Similarly, for like revenue, we have another model that will listen to like what they're doing, because some people get like really complex care. They're doing really advanced things. They're doing pistol squats and farmers carries, or other people they're just on the treadmill. And the charge amount and also how at risk you are is related to whether or not you're describing things appropriately relative to the codes that you're picking.
Okay.
So we try to help people understand when they're writing certain things, how they can be very accurate, so that they're not doing work that they don't get paid for, but also not asking to get paid for work that they can't justify. Because you end up with a compliance problem or a revenue problem. And this is all from reading the text descriptions, running it through our AI models, and then quantifying things so that we can give them back numbers so that they can interpret and track over time.
So your like loss function, or your objective function when you're looking at this data, is to look at what insurance companies are responding to in this case. Like you're reading it through and you're like going like, this was a bad outcome because they rejected this because you said the wrong thing, or because you did the wrong care, or because you didn't justify what you were trying, right? So you're able to then utilize that information and sort of guide it to understanding. So it's basically just doing like, that's actually very cool though, because that's a huge money saver, I'm sure. It's like a pre-insurance company like audit. You're like doing an internal audit at scale. You don't have to like have a human being devoted to that. So that's really, really cool. Okay.
Yeah. Which like you could probably look at like 6 patients over the course of a year. That's like, I think, the average that we sort of see if they're doing the human version. But our thing is just literally everything, like millions and millions of notes. We'll just go through the system, and then it'll look for all those little checkbox things that the insurance company wrote in text that then a human has to interpret it. And then they have to apply it to the notes that they read. And like, we just train the model to do those little checks. And then so we can get that number out.
Actually, that brings up, so do you do multimodal training? Like, do you actually have it read the documents physically? Like, because a lot of stuff is just filling out check boxes. So do you have like a way of like reinterpreting it as text so that the language model can look at that, or does it multimodally do it and actually look at the physical form of the document?
There's still sometimes where folks will do sort of like more written, like hand, like scribbled stuff. But fortunately, most folks have digitized to the point where like we don't have too much of that. Like we could do OCR and like go pull it in if we really, really needed to for some like edge cases. But most folks, fortunately, at least, it's coming in as like text, character or ASCII, that we can just kind of interpret.
So even something like if there was like a checkbox that said, I did this particular procedure, that checkbox would read as text, like some sort of marking there.
Sometimes we do have to take things that are like structured, like a checkbox or a button or a drop down, and then convert it into something that can be the same sort of format or text input, like sentences, basically, to go into the language model, because it's a language,
Yeah, that's what I was asking. Okay, so that makes sense then. That it's okay. So you're doing like a pre-processing step where you convert it into something that a language model is happy to understand. So okay, that makes a lot of sense.
There's a lot of gotchas on the pre-processing thing too. Just like the idea of like, okay, I would like a sentence, like is actually not trivial, because it outlines what if they missed the period, what if they wrote like 3 words, what is a sentence? And it's just funny how messy language is once you have to turn into something that you can give to the robot for the robot to be like, oh yeah, those are predictive.
We humans are a disaster, man. We're just all messy. That's really interesting. So the goal, obviously the goal of your company is to allow doctors primarily, it sounds like that's your client is doctors and healthcare companies, to get the best possible outcome from what they're doing for a relatively good economic outlay. I don't know. I may not be putting that in the best way possible. Probably have a way better pitch than that. But, I'm going back to that Johns Hopkins thing where it's like $5.5 million, to like, look at this. And it's like, yeah, if we could even save 10% of that, that would be a massive amount of money. And if you could cut that in half, that's like huge, right? So that's money that could be allocated someplace else to improve outcomes for people and things. So those are the products that you're doing right now. What sort of like vision do you have, or like North Star? Like, what's the thing in 5 years or 10 years that you want your company to be doing?
So I think you mentioned kind of like the Tesla AI metaphor, and
Right.
I want to make sure like what they've done is really like awesome. Like we're a tiny little company in comparison, like very early on, but I think the metaphor here might be helpful. So they have the labeling they did at the level, like the signs and the lane lines and all these different pieces. And that's kind of where we are now, right? We're labeling like, okay, you need to have this in your note, you need to have that.
Right.
But they're turning it into an understanding of like all of reality, so that they have like this model of the world for the car to drive through.
Right.
Our long-term goal is to have sort of a model of the patient where we can represent like how they're doing across time. Because I think if you can understand that really, really well, then now you can be like, okay, instead of like, you're gonna hit that car, so like move, it'd be like, hey, you're not getting better, like you're not getting enough, strength training in, or you're metabolically like unwell and like you're going to develop diabetes. And instead of turning the car wheel to get out of the way, we could help then suggest interventions with a really good understanding of their patient model, so that they avoid getting a disease or getting some other bad outcome. So that's like the long-term goal for us.
And that's a very impressive goal. I mean, that's the kind of thing. Yeah, I actually like that metaphor a lot. It's like you're doing the preventive care. You're trying to drive and see the potential accidents that are waiting for you up ahead, and to avoid those. So it actually does sound like there will eventually be some set of numbers, but of course that would be internal to the AI. It will fine tune itself and come up with some sort of vector of numbers that represents a patient. So even though it's not going to be human interpretable, there won't be like one number like 42 or something, but it will be interpretable by this model, and it will be able to compare humans given their demographics and their backgrounds and all of that stuff, and say, uh-oh, looks bad for you because you fit into these categories. And so that's great. Even if it's one of those things where it just gives your doctor a warning before your yearly physical. It says, hey, maybe look at these blood markers and maybe look at this thing, because this could be a potential outcome that could happen in 5 years or something, right? Or 10 years. So that's amazing. Okay.
And I really love that you bring up the preventative piece.
Right.
I still have this really vivid memory of being in training and like walking around the hospital. And I went to like a seminar, and I was like, oh, it was a nice seminar. I learned some really cool stuff. Like that was great. And I was going back to see my patients, and I was thinking about it as like, I feel pretty good right now, but my patients are not happy to be here. Like there is no good way to be in the hospital. And I sort of had that thought. I'm just like, you really have to figure out how to have that data to take this like crazy idea that we had at the time, so that you could do the preventative piece, right? To avoid, because once you're in the hospital, like, it's great to take good care of people, but they would prefer to have never been there.
Right. And I always say that the obstetric is the only positive reason to be in a hospital. It's like pretty much everything else is not good. Something has failed, and that's why you're there. And of course, a very close to my heart right now with my mother. She's actually literally going through chemotherapy as we're talking right now. So my brother is there with her, and he's taking care of her. But, but it's one of those things where if 5 years ago there had been markers and there had been things that said like, yo, you're very likely to develop cancer, and there could have been preventative steps that would have avoided all of this mess. And that would have been amazing. So it's not just for the doctors and for their good outcome, but it sounds like what you're saying is like, this is for societal good if this works. And and of course you're the person to make it happen. Sounds like you've got the motivation, you've got the talent, you've got the vision for it. I don't know. You want to leave us with anything? It's like, it's a pretty amazing vision. and I really love it. And I very much admire you working on this stuff. I don't know if you have any like thoughts that you want to leave everybody with about that.
It is definitely a big, vision and goal. We have a really good team that we've gotten together over the years. So I super, appreciate them and owe them for helping on that. And part of the reason that I was excited about getting to chat with you again is just to kind of share this idea of getting numbers out, improving things, and that healthcare and all these other systems you can do that with it, because we've made progress over the years, learning our way, and that we'll keep at it, because us or somebody else, I think there's so many things to improve still, for human health in other domains, and AI is giving us, I think, really great tools to make that progress. So I encourage folks to hopefully take this and run with it, and maybe make healthcare better. Beat us to it, because one way or another, I think it's just so important for folks to get there.
Cool. Wow, that's a great way to leave it. Thank you so much for being with me. I really do appreciate it, and I hope everybody else does. Of course, I will leave contact info and all of that other good stuff down below, and your company's website and all of that for people to look at. And again, thank you so much, Pedro. And yeah, everybody definitely check it out and think about living a more healthy life in the future. And thank you so much, and we'll see you in the next one. Bye-bye.